I'm going to ask my AI agent a question about my documents. Let's see how it responds. Can you get the name of the research documents I worked on 2 weeks ago? Let's see what happens here. It's getting the current time to basically ground it in the current moment. Then it's just running a Chroma query. And yes, yeah. So here you have it, very clean and accurate response. This is actually a document that I was viewing about 2 weeks ago, and I stored in my RAG pipeline. And then it can also give me the date when I actually stored or last worked with this document. What you've just seen is my AI agent answering my question using my own personal context. Basically, the setup is a RAG pipeline, takes or ingests my documents, and then I'm using an MCP server, which gives my agent the tools it needs to be able to work with my documents. In this video, I'm going to be showing you step by step how to build this entire system, and I'm also going to give you access to this repository where you can actually see how to set up this entire system. So you then get access to the code. You'd also know how to set up all of the dependencies as well. So yeah, let's get into it. So before we continue, let's do a bit of housekeeping. I'll be talking about some of the concepts that we encountered throughout this video. I'll be talking about RAG, MCP, and maybe some other things that will come up during the course of the video. If you already understand what these terms mean, you can just skip this part. But this is what a simple RAG pipeline looks like. So it basically takes your structured and unstructured data, convert those into chunks. So in this case, your structured and unstructured data could be documents, websites, documents with like tables. It could just be like any form of data that you want to store in your RAG pipeline. It converts all of that data into chunks. Chunks are basically your old document converted into smaller parts. You need to convert it into smaller parts so that retrieval can be fast and efficient. Because imagine we are storing like a large document of maybe about 500 pages or thereabout. Searching that data would be difficult and it would be very, very slow. So information retrieval in that case might not be very efficient. So we need to actually split that large document or any kind of data you give to your RAG pipeline into what we call chunks so that it's easier to work with. Then those chunks are converted into what you call embeddings. Embeddings are just numerical representation of the chunk itself. Then those embeddings are stored in what you call a vector database. Now, once you're done with that, one of the aspects is this. You basically would be using a text embedding model. I'll be showing you the one that I'm using in this demo. It's called sentence transformers. Yeah, I'll show you that eventually. You need a text embedding model to convert your chunks to embeddings. So when that text embedding model converts your chunks to embeddings, then we can give it to like the vector database to store for us so that we can retrieve it later. Now, whenever you make a query, the vector database compares to what it has stored and then finds the relevant documents for you, then returns those documents as chunks as well. So because we stored it as chunks, it's going to be returning it to you back as chunks as well. Then that chunk goes to your large language model. So it goes to like an AI model that converts the chunks or the information it has back to a more friendly or natural response. You basically can go back to the beginning of the video when I showed a demo of how my AI agents works. So what happened was the information got retrieved, the large language model formatted it in a way that seemed a bit more friendly or more natural, and then it gives back that response. The next thing I'll be explaining here is MCP. So MCP stands for Model Context Protocol. It's basically an open protocol or an open set of rules that helps your AI agents be able to talk with the outside world or be able to use what you call tools. Since the concept of AI agents came up, you basically had like your LLM move from just answering questions to being able to talk to the outside world, use tools like Google search and help you find the information. But the problem we had then was basically all AI agents had their own way of communicating with the outside world. It was not unified in any way. And yeah, that bred a lot of problems on its own. So we have MCP, that's Model Context Protocol now, as a standard that helps them be able to communicate to the outside world in a more standardized way. So that's basically what your model context protocol is. And basically you have what you call an OSTAP, which as your MCP client. So in my own case, the application itself that I was using to communicate to my RAG pipeline was the OSTAP itself. So then you have what we call an MCP server as well, which contains all the tools and all the resources that you need. So the client just connects to the server. Then the server can help it perform like tasks using tools. Yeah, basically do a couple of other things as well. These are all the tools we are going to be using in this video. So this is basically our tech stack. So first off, we need a way to be able to work with any documents, PDFs, websites. We need a way to actually be able to work with them. And what we'll be using to work with PDFs and websites to convert them into chunks is Docling. So Docling is a library from IBM that can take any kind of document and then it can basically just work with any kind of document, structured or unstructured. So it's a really nice tool. I'll advise you check it out. So the website is here. This is the Docling project, the github.io. You can just check that out right there. Then the next thing is Chroma. Chroma is basically my favorite vector database. I've been using it for a bit and I've really enjoyed working with Chroma. So it's basically where we store our embeddings, our chunks. Then the next thing would be the MCP server we're using in this case. So in this case, we're using the Chroma MCP server. So this is the website. I'll add the link in the description. It basically has like several tools that are supported that our AI agents can actually use to work with documents in our ChromaDB. So you can list collections, query collections, you can query for documents and so many other things. Then the next on the list is the sentence transformer. So this is basically an embedding AI model. So we'll be using this model with Docling to convert our documents into chunks, and then we'll also be using it with Chroma as well. This same AI model with Chroma as well to convert our text into embeddings as well. So yeah, it's a very small model, but it's really useful. So you can check it out here as well. To follow along with the video, you should download this repository first of all. It's very, very detailed. Basically tells you all of the things you need to install, gives you the prerequisites. So in this project, I have Docling running in two ways. So first off, you have what you call your Docling server. So it's basically a way of running Docling as a standalone server, such that you can actually just do everything you need using like an API. So the Docling server, basically this is like the API docs for that. But I will not be really touching Docling serve in this video. So I only just added it to show you what was possible. So it's optional, like I said, for remote processing. Rather, I'll be using like my local Docling installation in this case. So I have a Docling installed within the virtual environment that I'm working with. So yeah, you can just maybe see the Docling server and see the documentation rather, if you want. Next step would be setting up the Chroma MCP server that would give our AI agent the tools it needs to communicate with our vector database. So this is the repository for the Chroma MCP server I'll be using. I'll add a link into the description of this video so you can basically just take a look at the documentation that is present on this website. There are several tools that are supported. You have a tool for listing the collections in your Chroma database. You have one for creating collections, querying documents, getting documents, and adding documents. So you can just take a look at this documentation and just fiddle around with it. We'll be using the Chroma MCP server within Winsoft, which is the IDE that I use. So as you can see here, I already have it set up. This is the configuration here. So this is the configuration for the Chroma MCP server set up within Winsoft. So yeah. And as you can see, it's working. So all those tools that were present in the documentation are also like present here. They're all accounted for. You have all of their documentation as well here. So once you have that set up, the next step would be to run our Jupyter notebook. So you need to run the command, this Jupyter command within the Docling Chroma directory, and you also need to make sure that you run UV-sync earlier. That is what will you be using to install your dependencies. So both of those things need to actually be done in the order. So I'll just run this within this Docling Chroma directory here, and yes, so we have we have liftoff. Basically we have this document here called document processing local. So it's basically the local version of, it works with the local version of Docling in this case. Remember I mentioned that you have Docling serve, which helps you work with Docling as if it's like a server, but I will not be covering that in this video. Although I did include an example here that you can actually just use. But yeah, we'll be working with this document processing local file. So if you're also wondering about this file, this is just like a simple text file that just shows you how to insert like static text into Chroma, and yeah, just retrieve it as well. So yeah, but let's go back to what we are here for. So let's start. The first step would be to import Docling document converter. So this is basically what we'll be working with throughout this video when using Docling. So we imported like a document converter within Docling, which is what we are initializing here. Now, once we've done that, we also will be working with this specific PDF file. Let me show you what that file is. So it's basically a file from the internet. I didn't even really need to download it. Yeah, that's how powerful Docling is. Basically, I can just pull that file for you and work with it. So this is the file. As you can see, it's picture heavy. It's split into like two sections. It has so many things that might normally be complicated. So I selected this specific file for that purpose. There are also like several links within the file as well. Yes, so this is the file we'll be working with. Yeah, let's go back to our example. Now, the next step would be to fetch your file, then convert it into like a document object, which is what Docling will be working with. So yeah, basically this document object here. Then we are also going to be converting that to Markdown. So Markdown is basically a format that is easier for your AI agents, and it's basically easier for your AI to work with. So remember we'll be using like an AI model in this case to do the chunking and to do like the conversion to embeddings and all of that. So Markdown is something that is actually easier because it's basically just text, so it's easier for the AI agents or the AI model we'll be using to work with. So let me run this now. And then yes, I'm just printing what the output looks like so we can see it. So yeah, as you can see, it detected that this is a PDF file. Then it's going to convert it in batches as well. Yeah, there's quite a number of things going on in this case. You also have like OCR models working here to just try to extract the text from the document as well. All right, so it looks like it's done. Then let's just do a little bit of confirmation between the document and what was extracted. So yeah, the name of the document itself, startup, and then it's telling you there's an image above that. So let's go back to page 1. Yes, as you can see, startup technical guide for AI agents. So startup technical guide AI agents. Then it's telling you like there are some other images. Yeah, so I'm guessing the first image you pointed to would be this. Yeah. So it's basically a very good job for us. Yes, this is also something I love to see. It extracted the table of content as well, and then kept it as a table in Markdown format. So it just kept it intact. Yeah, this is beautiful. This is awesome. Yeah, just extracted everything. So I basically just threw everything on into this Jupyter notebook. Not a good practice, but yeah, just wanted to see what the extraction would look like. Now, the next step would be chunking. So like I said, all of this that has been extracted are basically going to be converted into what you call chunks. So once we are done with the extraction of the document in the text and conversion to Markdown, the next step will be chunking. So basically Docling can also do the chunking for us, and we will use what we call an hybrid chunker in this case. So if you come here, you can see the documentation for hybrid chunking. So this is the Docling website, by the way. So this is the model we're using, the sentence transformer model. It has a token limit. Yeah. So in this case, 304 is the token limit. Now, a naive way of doing chunking would be to split these large documents into chunks of 304 tokens each. But that becomes a problem because you find that information that belongs together, let's say for example like a list, or maybe like a table, or maybe like a paragraph. So once it's above that limit, you find that it gets cut into two different chunks rather than like them being kept together. And then when you are looking for information and that chunk is given back to you, you actually see that you have a chunk that is not complete. It doesn't have all of the information you need, and that is a very bad thing. So in this case, hierarchical chunking just looks at the context of your text or of a document. Basically, just looks at what just try to determine what belongs together using maybe context. So if it's a list, for example, it tries to keep that entire list together. If it's maybe like a paragraph, it tries to keep that entire paragraph together. So that's basically how hierarchical chunking works. Then hybrid chunking in this case combines that hierarchical chunking with what you call token aware refinements. So first pass of an hybrid chunker is the hierarchical chunking. Then the next pass is that it tries to make sure that they don't go the chunks that was gotten from the hierarchical step does not go over the token limits of the underlying model that we'll be using. So basically, once that first part is done, the next step would be to ensure that the chunks that are created from the first pass, that's the hierarchical chunking part, basically just stay under this limit of the model's maximum token limits, basically. Now, so yeah, I mean, putting the hybrid chunker, then yeah, pandas. I'm just going to be using this to display like a table that shows the content of our chunk. Then the maximum number of tokens. So this is 384. I got that from here. Then yeah, I created a chunker object using this hybrid chunker, and then this is the tokenizer we're using. In this case, this particular one. Then maximum number of tokens. Then yeah, I'm saying merge pairs. Yeah, as a setting for merging like smaller chunks together. So it's basically like an option. Docling is very very flexible that way. Then yeah, once the chunker has done its thing, I basically just get like a list of all the different chunks or an array of all the different chunks that was extracted from this document. And then I'm displaying that in the data frame. And I'm also displaying the length. That's how large a list we have. So let's run that. So this error is basically just a warning. It's nothing to really worry about. So that is done. Now here you can see the data frame. So here is just one chunk here. It's showing me the core. I'm only displaying the first one, by the way. So there are several others that I can display here. So the text is basically just the core concept of AI agents. So let's see if we can find this within that document. Yeah. So it's the very first section. This is nice. Well, I'm guessing that that is from this table of contents here, the core concepts of AI agents. So it's basically from that table of content. Yes, so the chunks are done. Okay, so there's something I would like to see here that was not printed. I want to see the length of the chunks we have. All right, let's do this for a minute. 157. Okay, this is nice. Once the chunks have been created, the next step is basically to take the array or the list of chunks. I iterate over them one after the other and basically get them ready for insertion or ingestion into our Chroma database. Now, so yeah, we're using the chunks that we created, the list of chunks we created here. We're taking each individual chunk. We're getting the text. So the text being the text from that particular chunk. So if you come back here, you can see chunk.text basically just takes that entire text from that particular chunk. Yeah, so we are putting that into this process chunks array. Then this is basically what the vector database will convert to embeddings and actually store for us. And then whenever we query, it's basically the same chunk that will be returned. So I just dedicated like its own array and to it, and I'm appending like the text proper to this process chunks array. Then the next thing is metadata's array. In the demo that I give, where I mentioned that the AI agent should look for a document I worked on maybe like 2 weeks ago. So what I did was to store the dates that document was created or like it was last updated. So here I just entered a static date. You can just make this more dynamic by maybe using the current date. But yeah, the metadata is basically what it looked at to determine the date that I last opened that document. So it also contains something like the book name. So if maybe, for example, I want to find some information based on a specific book that I stored in my vector database, yeah, this basically is what I'm part of what I'm also storing in the metadata. So metadata is just basically supporting information that would help you be able to either find what you're looking for more easily, or just gives more information about the document for your AI agents to be able to have more information to work with. So then I'm also storing the chapter where the chunk was found. Let's run this real quick. So this just puts everything in a data frame and it's just displaying to us. So the book name is this. For the book name would be the same for everything basically. Then table of contents, yes, chapter 2, exactly what I expected. For concept of AI agents as well, as you can see. So table of contents is in chapter 2. Basically, yeah, all of the information looks accurate in this case. The next step would be to initialize our Chroma and basically just insert the document into the Chroma database, that's into our vector database. So here I'm importing the ChromaDB, the HTTP client rather from ChromaDB. Then I'm creating a Chroma client instance. Yes, I'm just a collection or getting the collection if it exists. So this is the name of my collection in this case. Then here I'm taking the document, the process chunks rather, from earlier, and then I'm just assigning that to a document variable. Yeah, I'm assigning like a arbitrary ID as well. So you could maybe want to use a UUID or any other kind of ID, but basically I'm just assigning just a random ID in this case, and then I'm doing an offset. So why I'm doing an offset is basically that whenever, if the document already exists, do an update. If the document doesn't exist, insert. So yeah, there probably would be better ways to do this, but for the sake of the demo, I'll just do it this way. And then I'm printing the number of chunks that were actually saved as well in the Chroma database. So one fun fact though is that all of this saving to Chroma can actually be done using the Chroma MCP server. As you might remember, it has a tool for creating a collection, adding documents to it, and all of that. So all of this here can actually be done using the Chroma MCP server. You could basically just create an AI agent that would help you be able to insert documents into Chroma. Yes, so let's run this. The insertion is done. Yeah. Let's verify. So this is the documentation for Chroma. Yeah. Now we want to verify that we have data within the collection that was created. So because I just initialized Chroma without like putting up any settings or anything, so in this case, you need a tenant and you need a database. So if you did not set anything up, it will be default tenants and it will also be default database. Okay, so I think I need a collection ID here. So we need to get, yeah, we need to get the collection ID. So let's see, this should be default tenants, default database. Let's execute. Yes, so we have a collection called file demo, and let's copy the ID and use that here. Then let's just clear everything so we can retrieve all documents. I don't expect, yeah. Okay, awesome. So here you have it. These are all of our documents that we just inserted into Chroma. So this is the text for, these are the chunks basically. These are the IDs that I added. It's not written in the embeddings, but if you want to see it, you can basically just make changes to the query here that I deleted earlier. So here you could just add includes and then you add embeddings. You should be able to, it will give you the embeddings back as well. But yeah, I just wanted to verify that the information is in Chroma. I don't really want to do anything with it yet. Yes, perfect. So we've inserted our documents into the Chroma database. So if you come to this repo here, yes, the repository for this video, you will see I, under like query your documents, I have a prompt here that basically just gives an initial instruction to our AI agent to tell it how it's supposed to function and how it should answer our questions. So you can just basically paste that prompt here. I just modified it a bit. I removed the collection because I basically want to show you how the MCP server works. And I told you to confirm with okay. So he told me it's understands what I'm saying. Now, next I want it to confirm to me that it has access to ChromaDB. I'm using CloudOpus 4.5 by the way, but you can use any AI model that you want. So yeah, it really doesn't matter. It just needs to have like agentic capabilities. So let's see. Yeah, it's calling the Chroma MCP tool, and yes, it tells me it has the file demo collection, which is cool, which is pretty cool. Now let's ask a question based on this document here. Let's ask what the two approaches are, what the two options are for building an agent. And let's see how it does with that question. Or are the two options for building AI agents? Yeah, that is just wonderful. So he was able to query quite intelligently. Yeah, let's see how it did. So the collection is file demo, two options for building AI agents, and then he got these documents back. He got about, let's see, 5 documents back. Yes, so here's Google Cloud. Yes. Yeah, this is wonderful. This is really nice. So the Chroma database basically was able to like understand what we are looking for, and then it gave it the documents that most likely would match our query the most. So here are the distances. So distance is basically like a confidence score that tells the AI agent how confident the vector database is in the answer it's giving it. Yeah, and I'm also pretty happy with the result it gave. He was able to distill this information into these two approaches here, which matches what we have. So here you have the code first approach and the application first approach, and yeah, that's matches exactly what we're looking for. So let's ask a question: what sort of document is this? Yeah, awesome. So based on the metadata from ChromaDB collection, the document is a research document. The title is Startup, and it was created on this date. Chapters, at least 30 chapters, based on chunk metadata shown. An MCP server, or since model context protocol, is basically supposed to give your AI agent tools that you can use in performing different tasks or communicating with the outside world. One other thing I can see that we could do with this is maybe store documentation for like your company, your style. For example, you could store a brand guide within the Chroma database, and then whenever you have vibe coding, you could basically just have that AI agent that you're vibe coding with. You could have it check for your brand guide within your vector database as well. So maybe for example, when you tell it to design something, you could get your brand colors directly from the vector database and use that, or you could get maybe like the different copy or the different images like you like to use. You could just get all of that as well and use those within your vibe coded website or app basically. So there are a ton of different approaches that can be done. And another thing I like about this approach is basically you don't necessarily need to like define any kind of schema or define how information is going to be retrieved from your vector database. I've seen that approach quite a number of times, and I think just using an MCP server in this case is much cleaner. So yeah, I prefer this approach much more. Yeah, let me know what you think in the comments.